Welcome to Spring LIB.
Hi everyone, so what we have here is a particle with a mass of 0.5 kilograms that is moving along a horizontal slot due to the rotation of an arm. We know the arm is rotating at a constant angular velocity of 0.2 radians per second, and the path of the ball is given by 0.5 times the secant of theta. And we also know the arm is accelerating at 3 radians per second squared. So what we're asked to solve for is the tangential force, and basically the force from the rod and the normal force of the slot when theta is equal to 30 degrees. The way we're going to do this is apply our knowledge of rotational motion and also develop some free body diagrams of this particle and apply Newton's second law to develop equations of motion and solve for these forces. So let's go ahead and get started. We know that r is equal to 0.5 secant theta. Therefore, we can solve for r dot, and that's equal to 0.5 secant theta tangent of theta times theta dot. Then we can solve for r double dot and take the derivative again. And we see that this is equal to 0.5 secant theta tan squared theta times theta dot squared plus secant cubed theta times theta dot squared plus secant theta tan theta times theta double dot. Now, since we know that theta is equal to 30 degrees, we know that theta dot is equal to 2 radians per second, and we know that theta double dot is equal to 3 radians per second. We can go ahead and directly solve for r dot, and r double dot. We'll find that r is equal to 0.574 or 774 meters. R dot is equal to 0.67 meters per second, and r double dot is equal to 4.85 meters per second squared. Using these pieces of information, we can solve for AR. The acceleration in the radial direction is equal to r double dot minus r theta dot squared, and that gives us 2.54 meters per second squared. Acceleration in the theta direction gives us r theta double dot plus 2r dot theta dot, which is equal to 4.399 meters per second squared. Now let's go ahead and draw a free body diagram. Here we have the mass, the particle, acceleration in our r coordinate direction and our theta coordinate direction. Here's our normal force coming from the slot, and here is the force coming from the rod, and here is our weight force. And this is the angle theta of equal to 30 degrees. So what we can do is we can resolve our forces in the r and theta directions and apply Newton's second law to develop equations of motion. We can first do it in the radial direction, so the net force in r is equal to m times ar. So we can resolve our forces and say n cosine of 30 degrees minus mg cosine 30 degrees is equal to m ar. Isolating n gives us an n equal to 6.37 newtons. Similarly, we can do our free body diagram and apply Newton's second law in the theta direction and say that this is equal to m times 8 theta. And this gives us f plus mg sine 30 minus n sine 30 is equal to m times 8 theta. Isolating f gives us that f is equal to 2.93 newtons, and that is our final answer.